Hi, welcome back to Mr. Farina's algebra class. Today we'll be learning a second method for solving systems, and that is elimination. The past few days we've been talking about substitution. And we use substitution when one of the variables is easy to get by itself, if not already by itself. So what happens if we cannot get one of the equations, one of the variables in one of the equations by itself? What we generally use is the elimination method. Now, just like substitution, when we use elimination, we have one goal in mind, and that is to break the system down to, I don't know why that's jumping there, but it is, down to one equation with one variable. Alright, now we do it a little differently. The first step is we basically put both equations in standard form, and that's ax plus by equals c. But when we do this, we want to align the like terms vertically. So what do we mean by that? Well, I'm going to have something like 3x plus 2y equals 4, and then I want to have something like 5x minus 3y equals 2. Notice, my like terms and my constants are aligned vertically. Then, we're going to multiply one or both of the equations by some number to create opposite coefficients. Alright, now I'll explain this step in a minute. Then what we're going to do is add the equations vertically. Alright, after this step, our goal is accomplished. Our system will be broken down to one equation with one variable. Now, once we have it down to one equation, one variable, we solve for the remaining variable. Alright? Then, last, just like substitution, once we find one of the variables, we plug the value of the variable we found into one of the equations and solve for the other variable. Now what we mean by step 2 is when we go to solve these systems, we want one of our variables to eliminate. And how do we do that? We have opposite coefficients. Alright, such as in this example here. If you notice, 4x and negative 4x are opposite coefficients. When I add these together, I would get 0x, or basically eliminate that when I add the equations vertically. So what we want to do is, multiply one or both equations. So say I have, 5x plus 3y equals 2, and then I have 6x minus 2, now we'll go minus 9y equals 5. Right now I don't see opposite coefficients here. These don't add up to 0, these don't add up to 0. So what do? Well, if I take the top equation and I multiply it by positive 3, right? When I multiply everything in there, I would end up with 9y and negative 9y. Those would add up to 0. Alright, so we force elimination by multiplying the equations by some number. Now the reason that works is if I take any equation such as 3 plus 2 equals 5, I think everybody would agree that's true. Well, if I multiply everything in that equation by some number such as negative 2, negative 2 times 3 is negative 6, negative 2 times 2 is minus 4 equals negative 2 times 5 is negative 10. Does this equation remain true? Yes. But it's critical to know and understand. You have to multiply everything in the equation by that number. Okay? Let's look at a few examples here. Example 1, right? We look at both of our equations. They're both in standard form, so that's a good start. Now, I ask myself, if I add this vertically, do any of the variables eliminate? Well, looking at the x's, if I add 2x and negative 2x, would that add up to 0x and eliminate the x's? Yeah. So basically that's what I'm going to do. I'm basically going to add these two equations vertically. The x's eliminate, and now 3y plus 5y gives me 8y equals 11 plus 13, 24. And now I can solve for y real easily by dividing by 8. And y is equal to 3. Now, remember the solution is in an ordered pair that makes both equations true. Right? So now I have to plug it in and get x. So I pick one of the equations. It doesn't matter which one you choose. 2x plus 3y equals 11. I'm going to substitute 3 in for y and solve for x. 2x plus 9 equals 11. 2x equals, subtract 9 from both sides. 2x equals 2. Divide by 2. And x equals 1. I have x and y now. So the ordered pair solution to this system would be 1, 3. Okay? Make sure you're taking good notes here. Now in the next example, if I look at both of my equations, are they both in standard form? No. Now the first equation happens to be in standard form. So I basically rewrite it. Now, in order to put the second equation in standard form, my first step has to be to subtract 3x from both sides. When I subtract 3x from both sides, I get negative 3x plus 4y equals 14. Now I'm going to take this equation and I'm going to line it right up underneath this other equation. Negative 3x plus 4y equals 14. Notice here, when you look at your y's, if you add the two equations together, does it eliminate the y's? Yes. And that allows us to solve for what variable? X. 8x minus 3x is 5x, but by y's equals negative 4 plus 14 is 10. Keep track of your signs at all times. Divide by 5, and I get x is equal to 2. Alright, now I still have to find y. So I pick one of the equations to solve for. I can go back to one of these two equations or the original equations. I'll take this equation here to plug it back into. So 4y equals 3 times, I'm going to substitute 2 in for x, plus 14. So 4y equals 6 plus 14. 4y equals 20. Divide by 4, and y is equal to 5. And the ordered pair solution for this system is 2, 5. Okay, so again, we had to put this second equation in standard form, align it vertically, and notice the y's eliminate, which is good for us. Okay? Alright, let's look at another example. If I look at example 3, both of my equations are in standard form, but if I add the x's vertically, I get 9x. If I add the y's vertically, I get 6y. Neither of my variables will eliminate. Well, what do I do if this happens? Well, what I do is I pick one equation to basically multiply by some number to force the opposite coefficients. Now, if you notice, if I make one of these 3y's negative 3y's, 3y minus 3y would give me 0. Therefore, I have to pick one equation to multiply by some number. Well, I'm going to leave the top equation the same. 4x plus 3y equals 2. But the second equation, I'm going to multiply everything by negative 1. Because what I'm doing is, when I multiply by negative 1, negative 1 times 5x is negative 5x. Negative 1 times 3y is negative 3y equals negative 1 times negative 2 is positive 2. And if you notice, now I've created opposite coefficients for the y's, and they will eliminate. So, when I add the equations vertically, 4x minus 5x gives me negative x. The y's eliminate, equals 2 plus 2 is 4. Now I could easily solve for x. So x equals negative 4. Once I have x, I still have to go and find y. So I pick one of the equations to plug it into. This one, I'll take the top equation. So 4 times, we're going to replace x with negative 4 plus 3y equals 2. That gives us negative 16 plus 3y equals 2. And now it's an easy equation to solve from here. Add 16 to both sides, 3y equals 18. Divide by 3, and y equals 6. I now have x and y, so I can gather my ordered pair solution. Negative 4, 6 would be the solution. Okay. Alright, example 4. If I look at this, are both my equations standard form? Yes. But, although they're in standard form, do I have opposite coefficients? No. So what's the easiest variable to our equation to multiply to create those opposite coefficients? Well, if I multiply the top number by some number, can I multiply 6 by some number to get, 2? Or 5 by some number to get 3? No. But is it easy to multiply 2 by some number to get 6? Yes. Therefore, we're going to keep the top equation the same. But remember, I need opposite coefficients. I need one to be positive and the other to be negative. So I'm going to multiply the second equation. I'm going to eliminate the x's now, because I'm going to turn this 2x into a negative 6x by multiplying the entire equation by negative 3. Negative 3 times 2x gives me negative 6x. Negative 3 times 3y gives me negative 9y equals negative 3 times 5 is negative 15. Now look what happens. If I add the x's vertically, they eliminate. Now 5y minus 9y, negative 4y. 19 minus 15 is 4. And when I divide by negative 4, y is equal to negative 1. And again, I take that value, plug it into one of the equations. I'll use 2x plus 3y equals 5 because the numbers are smaller. So 2x plus 3 times negative 1 equals 5. 2x minus 3 equals 5. Add 3. 2x equals 8. Divide by 2, and x equals 4. Now I can gather my ordered pair solution. 4, negative 1. Alright, one more example here. Alright, example 5. Remember, you can rewind any of these examples and look at them at any time. So, the first equation is in standard form already, so I'll rewrite it down. 4x plus 5y equals 35. But my second equation isn't. So I'm going to put this in standard form, I'm going to subtract 3x from both sides. When I do that, I get negative 3x plus 2y equals negative 9. Now I'm going to take this equation and I'm going to write it vertically underneath the other equation. Negative 3x plus 2y equals negative 9. Now when you look at this, there's no easy way to just get away with multiplying one equation. Because is there anything I can multiply 4 or 3 by to create opposite coefficients? No. How about 5 or 2? No. So I have a couple of options. What can I turn 4 and 3 both into to have opposite coefficients? Well, if I make this a positive 12x and this a negative 12x, when I add them together they would eliminate. Now I could potentially do the same thing for the y's, but instead of making them 12x negative 12x, I could make this 10y and this negative 10y. But because I already have the opposite part with the x's, and then I'm going to choose the x's to eliminate. So what I'm going to do is I'm going to multiply the top equation by 3, because 3 times 4x will give me the positive 12x. I'm going to multiply the second equation by 4, because 4 times negative 3x will give me negative 12x. So I go ahead and multiply these equations to get my new ones. 3 times 4x, is going to give me 12x plus 3 times 5y is 15y equals 3 times 35 is 105. Now 4 times negative 3x is negative 12x. 4 times 2y is 8y. And then 4 times negative 9 gives you negative 36. Now, when you look, the x's go bye-bye. Alright, and 23y equals 105 minus 36 would be, so 105 minus 36 is going to be 69, and when I divide by 23, I get y is equal to 3. So again, I can pick any equation to go back to and solve for x. So I'll take the very first equation, 4x. Computer's acting goofy in that spot. So 4x plus 5y equals 35. I'm going to substitute. Why did that disappear? I'm going to go ahead and substitute 3 in for y. So 4x plus 5 times 3 equals 35. 4x plus 15 equals 35. I will subtract 15. 4x equals 20. And when I divide by 4, x is equal to 5. So my ordered pair solution for this system is going to be 3, 5. Alright, this should give you a head start on the homework. If you have to go back, keep the Chromebook, and if you have to go back and look at some of the problems, please rewind and go back and look at the problems. Alright, I'll see you tomorrow.